And welcome back. So I wanted to begin today's lesson with a review of a couple of topics you're already familiar with. The first is being C++'s resource acquisition is initialization paradigm, and then also to just revisit kind of what a destructor's, what's going on during the destruction object process of an object. So resource acquisition is initialization. The C++ model of resource management, RAII as it's known in short, is based on the use of constructors and destructors to specify the object construction, that is initialization process, and destruction, so the cleanup or freeing of any resources that were acquired during that object's lifetime. For scoped objects, destruction is going to be implicit at the scope exit. So when that name goes out of scope and provided there's no references to that object, the lifetime of said object would then be over and the destructure would be invoked implicitly. For objects placed on the free store, so dynamically allocated objects that we constructed using new, delete, when we invoke delete on an object's address who's residing on the free store, that's going to implicitly have the object whose memory is being deallocated destructor to fire off. And then in addition to this, we're also communicating or pinging the free store manager and going, hey, we're no longer using this object. Feel free to reclaim its space for use in something else. So this was taken from the CPP core guidelines. The content on this slide, the editors of that are the original implementer of the C++ programming language, Bjarne Stroustrup, and then also Herb Sutter, who's a very well-known name when it comes to the C++ programming language. So C++ language enforced constructor-destructor symmetry mirrors that in resource acquisition and the release through functional pairs such as fopen and fclose for files, and then also new and delete for the construction and destruction of dynamically allocated objects. Whenever you deal with a resource that needs paired acquire release function calls, whether it's opening and then closing a file, allocating and then deallocating memory on the free store, we can encapsulate that resource in an object that enforces the pairing for you. We would go ahead and open the file or acquire the resource, whatever it may be, in the constructor for our type that we're creating, and then we'd go ahead and release it in the destructor when an object of that type is being torn down. RAII is a basic technique for resource management based on scope. And the key idea is that the ownership of a resource is given to a scoped object. So what we're going to see here, and this is going to kind of be the mantra of the unique pointer that we're going to talk about in a bit more detail in the remainder of this lesson, is that we're kind of associating ownership of some sort of resource with a particular object. We go ahead and acquire that resource in the constructor. So we open, allocate, whatever it may be. And then when the lifetime of the object that's holding the resources up, the object's destructor will then go ahead and release the resource at the end of its lifetime. Now, this is kind of a combination of new information and things you've seen previously within this course. I just want to go through and reiterate and maybe clarify kind of the order of destruction of an object. So this was taken from some Microsoft documentation. The link is there at the bottom of the slide. But here's what's important. When an object goes out of scope or when an object is deleted, the following order of destruction occurs. The class destructor is called first and the body of the destructor function executed. Then destructors for non-member objects are called. So this could be like, let's say your class, the type you've defined owns a standard template library vector. That's one of its data members. So directly after the destructor has been called on an object of this type you've defined, the next thing that's going to happen is the standard template library's vector that your object owns is going to have its destructor fire off, excuse me. And then we'll see destructors for non-virtual base classes are called, and not as, in the 3 and 4 aren't as relevant for today's discussion. But after 3, we then see the fourth kind of step in this process is any destructors for virtual base classes is then called next. So just, I mean, we're focused on 1 and 2 here because it's going to have implications when we begin talking kind of about the unique pointer in a bit more detail. So with that, let's go ahead and talk about how we can apply a unique pointer to some of the data structures that we've built together or built in your machine problems to date. When going through this process, I'll also kind of communicate some additional information about the unique pointer and how it's operating in the specific scenarios that we will discuss. So with that ado, let's go ahead and move on and see the unique pointer in action.